In this video, we're going to talk about determining whether or not a compound statement is true or false. So when we define a statement, knowing that something is a statement doesn't require that we know whether or not the information communicated is true or false. It helps from the standpoint of just interpreting what we're reading to know whether or not something is true or false, but that's not an essential. Remember, a statement is just going to be a sentence that is either true or false, but not both at the same time. Knowing which is the case is not essential. So what we want to focus on more so is the structure. Suppose we're looking at a compound statement whose contents we don't know anything about. Maybe our statement is something related to quantum mechanics and we know nothing about quantum mechanics because that's super complex. Well, if we are talking about how our compound statement is structured, then whether we know anything about the particular content, the particular material being discussed, doesn't actually have any bearing on the logical truth value of our compound statement. That has to do with how the statement is structured. So what we want to talk about is all the information we would need to determine whether or not our statement is true or false, our compound statement is true or false, aside from what we can say about the specific content in a particular discussion, a particular argument. So the way we can logically sort of structure a discussion about whether a compound statement is true or false, the conditions when it would be true or false, is using what we call a truth table. So a truth table is essentially going to organize all the possibilities. What we're going to focus on is, suppose we have two individual statements and our compound statement consists of two simple statements. If we know the simple statements but maybe don't know whether or not they're true or false, what we're going to consider is all the possibilities. Well, what if they are both true? What if they are both false? What if one is true and the other is false? What we're then going to focus on is how have we structured our compound statement? Based on how the compound statement is structured, well, what would result from the two statements, original statements being true? What would result from the two original statements being false? We're focusing on the structure. Does the structure of the compound statement lead to something that's true? Does the structure of the compound statement lead to something that's false? So at that point, all you would need to determine whether or not an argument is valid, whether or not a statement is valid, is to then supply the information about the original simple statements. Once you have that information, the structure can then be used to determine the actual conclusion. Is the actual conclusion a conclusion of truthfulness? Is it a conclusion of falseness? So each individual connective, each individual operation we can use to combine statements has its own truth table. It has a different combination of truth values depending on what sort of values we have for the original simple statements. So the first one we're going to look at is negation. How do we know when a negation is true? How do we know when it's false? Well, we've actually already talked about that. If we start with something that's true and we negate it, then automatically we get something that's false. If we start with something that's false and negate it, then we get something that's true. It's a binary operation. We go from one to the other. So this is what a truth table is going to look like. The first column or columns in the truth table represent the simple statements. And in that column or columns, we're going to list all the possible combinations for different statements being true and different statements being false. Now, negation only applies to one statement. It only applies to one at a time. If we then were to apply it to multiple statements, well, we've already combined them together. And so they've already been combined into one statement, and then we just apply the negation to that whole thing. So for this particular table, all we need to do is to consider the original statement. Is it true? Is it false? Based on these individual values, the next column in the table is where we indicate the result we get from applying that particular operation, in this case, the negation. So if we start that something's true, start with a statement that's true and negate it, we get a statement that's false. If we start with a statement that's false and negate it, we get a statement that's going to be true. So the final column in every truth table represents the actual conclusions you draw if you started with those original truth values for the original statements you have. Now the next one we're going to look at is conjunction. Remember, conjunction means and, so one and the other. A conjunction is only true when both statements are true. In any other situation, we consider the conjunction to result in something that's false. Now, conjunction joins together two simple statements. So when we define the truth table, we're looking at two columns. We're looking at two statements and all the different combinations for truth and for falseness. There's a traditional order we put them in as well, and we're always going to follow this particular order. So let's say we have the statements P and Q. We're going to write them in alphabetical order, so columns in alphabetical order. We're going to start with all the possibilities where P would be true. So P could be true and lead to two possibilities. P could be true, and then Q could also be true, or P could be true, and then Q could be false. Okay. P could also be false. Well, P could be false and Q could be true, or the last possibility is that both of them would be false. So look through this and take a minute and make sure that it makes sense that all the possibilities have covered. You can either think of them as both being true, both being false, or one or the other in both directions. So that is going to cover all the different combinations for how the individual statements could have a truth value or a value of falseness. This is going to be the standard order we write in every time so that we're consistent from table to table and so that we know we're really looking at the same thing every time. And then again, the conjunction of these two statements, one and the other, that combination, that compound statement that results, is only considered to be true when both of the original statements are true. So if P is true and Q is true, then P and Q results in something that's true. If P is true, but Q is false, well, that false overrides the true. So that means that results in a false statement. If P is false and Q is true, again, false overrides true. So we get a result that's false. And then if they're both false, then false and false gives us false. So notice in this case, there's only one situation where we get a result of true. It's only when both of the original statements are considered to be true. So that's going to be conjunction, one and the other. Now, disjunction, we think of disjunction as being one or the other. So a disjunction is going to be true when either statement is true. In other words, only one of them has to be true. Now, remember when we use the word or, logically, we're talking about an inclusive or. So one or the other and possibly both. So all that we require is one statement that's true, but if both are true, then that just means we have more than we need. It's more than sufficient. It's still going to result in a true conclusion. So same possibilities for P and Q. They could both be true. We could have true, false, false, true, false, false. These are all the original possibilities for how P and Q could relate to one another. So if we take their disjunction, true or true results in a true outcome. True or false, well, as long as we have one true, the outcome is true. False or true, we end up with true. Only in the case where both of the original statements are false would we say P or Q results in something false. Now, there are also truth tables for our conditional, for our biconditional. We're not going to look at those here. So we're just going to focus here on negation, conjunction, and disjunction. We're just going to focus on compound statements involving those particular operations. So before we practice actually generating the full truth table, let's just look at one case at a time. So you can actually look at an entire statement and just knowing where you start with the original simple statements. Is one true? Is the other false? Vice versa. Are they both true? Are they both false? You can determine whether or not a statement is true just based on using these relationships. What happens when you negate something that's true? What happens when you combine two things together that are false? Those kinds of things. We're just looking at one case at a time. Now again, this is going to depend on whether or not we started with true statements or whether we started with false statements. So here are our statements. They're specific statements where we don't have any type of information we need additional. We should be able to determine whether or not these are true or false. So the first statement is the inequality. 10 is greater than 4. Well, that's definitely a true statement. So we know in this case we're working with P as a true statement. Q is the statement that 3 is less than 5. Well, again, that's also a true statement. So in this case, for each of the compound statements we're going to look at, we're starting with two statements that are true. Both P and Q are considered to be true. So what if we structured a compound statement using P and Q? In other words, 10 is greater than 4 and 3 is less than 5. What we're ultimately doing now is, rather than thinking of the statements themselves, what we want to think of is their truth values. In this case, both of them are true. We want to determine what is this connective going to do to those particular statements with those particular truth values. So in this case, P and Q is the same thing logically in terms of the truth values as saying true and true. Well, we know the outcome whenever we have one and the other. As long as they're both true, the outcome is going to be true. So that means this whole statement has the value true. This statement would be true just based on the original statements we're combining together. Now this would be P and not Q. So P and the opposite of Q. So the opposite of Q, 3 is less than 5. One way of saying the opposite is 3 is not less than 5. You could just put a slash through it. Well, P, we know P is a true statement. What happens if we say not Q? Well, remember what negation does. Q was a statement that was true. So when we negate Q, we end up with something that is false. So now we're looking at true and false. True and false. Well, remember, and the conjunction will only result in something true when both of the original statements we worked with, both of the ones we're combining together, are true. Now we're combining one that's true with one that's false. So the outcome for conjunction is going to be false. Now what about disjunction? P or not Q. So almost the same thing, but now our conjunction is a disjunction. So P, which we know is true, not Q. Q is true. We take not Q. We know not Q is going to be false. So true or false. Well, disjunction is going to be true as long as at least one of these statements we're combining together is true. So true or false, at least one of them is true. So true or false results in a true outcome. And then last, not P or not Q. Not P, well, P is true, so not P is going to be false. Q is true, so not Q, also going to be false. So we have false or false. If we're combining together two false statements in this way, it's going to result in a false outcome. So this particular statement would be false. Now we're going to use the same kind of idea when we look at the truth tables, but the truth tables are going to cover all possibilities. In other words, what if you didn't know exactly what P and Q were? If you don't know exactly what P and Q are, then you have no way of knowing whether or not each is true or false. What we want to look at is all the possibilities. If we don't know what P is, we don't know what Q is, we at least know how they could be in relation to one another. Both could be true, both could be false. One could be true, one could be false in both directions. What we want to analyze now again is this structure. Based on how the compound statement is structured, well, what would result based on the different truth and falseness values of the original statements? We want to look at all the possibilities, all the different possibilities, just based on the kinds of original statements we could start with. Just looking at the structure, not looking at specific original statements. So we'll start small and then we will add on as we go. Okay, so we want to take each of these compound statements and we want to construct a truth table for it. What we're going to do is we're going to layer in operations. So just like when we translated things from symbols to words, from words to symbols, when we applied set operations, you do one thing at a time. You look at one operation at a time. So as we generate these truth tables, we're going to apply one operation at a time, following those rules that we have for essentially order of operations. So what has to happen in what order? We're going to layer in one operation at a time. So each additional column we put onto the table is then going to add an additional operation. If we've done it correctly, then by the time we get to the very last column, we'll have generated the entire compound statement, and the final column will have the actual truth and falseness values for all of the original different possibilities for our original simple statements. So let's start with a simple one. This one only has two operations. So we're negating P and Q. So here's our table. Forget about this for a minute. We'll look at this in a minute. First columns, we just want to talk about the original statements P and Q. Now notice we don't know what P and Q are. They're just arbitrary statements. All we know is that P could be true or it could be false. Q could be true or it could be false. We want to look at all the different possibilities for how one could relate to the other. So they both could be true. We could have true false, false true, or false false. You will get in the habit of writing these so many times that you don't even think about it. You'll just write those just almost blindly. So we're going to go one column at a time, layering in one operation at a time. So if we were to go based on the rules here, we know we have to start inside parentheses. So the first operation we want to apply is going to be the conjunction. We want P and Q. Based on all the different values we have for P and Q, we want to know what's the result if we combine them together with conjunction. Well, true and true is going to give us true. Any of the other possibilities, we know we're combining with at least one false. True and true is always true, but any other combination, if we have a false statement involved, then the conjunction is going to result in something false. So we have true, false, false, false. Now, after we've done the conjunction, we have to negate the result. So the next column we generate is going to take the previous one, and we're going to take those results and we're going to add on the next operation. So you'll notice that once we've done this column, we actually don't need the original two columns again. Each time we're building off of the previous intermediate results. We're taking the results we just found, and now we're just negating those. We're negating the most recent result. So we have true, false, false, false. We're now negating each of those values. So if we take a true and negate it, we get a false. We take a false and negate it, and we get a true. So that's going to be the case also for those bottom two rows. So the last column represents all the possible values for any type of statement that has this particular structure. So what could we say about a statement that's structured in this way? What we would be able to say is that if both of the original statements were true, regardless of what they are, but if they were both true, then this particular statement would result in something that is false. It would result in an actual statement, an actual idea that would be false. If we started with a true and a false statement, the compound statement would have a value of true. If we had a false true, it would also be true. If we had a false false, it would also be true. So all we would need to know to determine, well, what are we looking at in a specific case? We would need to know our actual P and Q, and we would need to know which one of these four possibilities it falls under. Based on the case it falls under, we would know what to interpret from that particular compound statement. Okay, let's try another one. Not P or not Q. Okay, now we have three things here. We have two negations and we have a disjunction. Start with our original statements, P and Q, list all the different true and false possibilities, and then again we're going to layer in one operation at a time. So you can think of negation kind of like a complement. The complement operation for sets, you know, you had to do it one at a time, one set at a time. You had to do that particular operation before you could combine anything together. So disjunction combines statements together. Negation is applied to individual statements. So that means these two negations have to be done before we can join them together. So working left to right, the first thing we're going to need to find is going to be not P. So that's going to be our first column, not P. All I'm using now is the column for P. I want to express the negation for each of these possible values. So if I start with a true, I negate it and I get a false. If I start with a false, I negate it and I get a true. Okay, so that's going to take care of this operation. Now I can't join it together with anything until I've also negated Q. So my next column, I'm going to add in that negated Q. Now I'm looking at Q. So just looking at Q, just negating Q. So true negated becomes false. False negated becomes true. And then true false, false true. So what do I have so far? I have my negation here. I have my second negation. The only thing remaining to do is to join those together. So my last column is going to join them together. What do I need and what don't I need? Well, I need not P, I need not Q. Those are being joined together. But notice at this point, I no longer need my original values because I'm building off of my intermediate values. I'm taking each of these results that I previously found and I'm joining them together with disjunction, one or the other. So false or false results in false. False or true results in true. Remember, only one of them has to be true to say that the disjunction is true. True or false results in true, and then true or true results in true. So notice here, the last column is exactly the same as the last column above. That's because these two statements are actually logically equivalent. They're true under the same conditions, they're false under the same conditions, which means they are logically equivalent statements. So if we were to see a statement that's structured this way, we know that if the original statements are both true, then this statement as a whole is going to be false. And then in any other situation, based on having P, based on having Q, based on their truth and falseness values, any other combination, the compound statement would have a value of true at the very end. Okay, let's add in another layer. We have a negation, we have a conjunction, we have another conjunction, we have another negation. So 4 different operations here. More than likely, that means we're going to need 4 columns, additional columns past the original ones. If we need to layer in 4 operations, we need 4 columns in order to do that. So notice here we only had 2 operations. We had 2 additional columns. Here we had 3 operations. We had 3 additional columns. Here we have 1, 2, 3, 4 operations. So we have 4 columns. So start with the original values. P could be true, Q could be true or false, all of those combinations, and then we want to layer in each of the operations. Now here we have parentheses. We know we need to start inside parentheses. We can't do anything on the outside until we take care of stuff on the inside. Now on the inside we have 2 operations. We have a negation, we have a conjunction. Out of those 2, the negation is going to have to come first. We can't combine anything together until we've simplified that negation. So that means our first column is going to take P and it's going to negate it. So P, all of the different values, negated, true becomes false, false becomes true. So those are going to be the values for not P. Now I'm going to take not P and I'm going to combine it together with Q using conjunction. So at this moment, I don't need the P column. I'm just looking at not P and I'm looking at Q. I'm combining those 2 together, again using conjunction. So remember, conjunction is only true when both of the statements being combined are true. If either of them are false, the result is false. So true false results in false. False false is false. True true is true. False true is going to be false. Okay, so this now covers our parentheses. That represents everything in parentheses. So what would need to come next? Well, now we can go outside parentheses. We still have 2 remaining operations. We have another conjunction, we have another negation. Now the negation comes before the conjunction. We have to apply it and simplify that statement before we can combine things together. So our next column, we're going to add in not Q. Now be careful, don't mix up which columns you're looking at. If you have a couple sheets of paper, something like that, as you go, you may want to cover up what you don't need so that you're only looking at what you do need. Because in this case, all we're doing is negating Q. The rest of the columns we have don't actually come into play at this moment. So we're taking all the values for Q, we're negating them. So true becomes false, false becomes true, and then true, false, false, true. Now that's all but one operation. So here are the layers so far. We negated P, we combined it with Q, which then gave us everything in parentheses. So here, that represents everything in parentheses, all the different possible values there. We negated Q, and that gives us all the values there. So all that remains to do is to take those results and combine them together with conjunction. So what do I actually need? I need the result here, so I need this column, and I need the result here, so I need this column. So all of these results are no longer needed. These are the two things being combined together in our last column. Now again, we're combining with conjunction using the word and. So the result is only true if both of these statements being combined are true. So false and false is false. False and true is false. True and false is false. False and true is false. Now this one's kind of interesting. Look at the result. The result is always false. So what that means is that if you ever were to see a statement structured like this, it would be very convoluted to express a statement like this in words. But say you had it written down and you had a moment to break it down and think about the actual structure. What this now tells us is that any compound statement structured like this could never be true. Regardless of the actual statements involved, based on how this compound statement is structured, it could never possibly be true. Just because the structure is just a logical fallacy. There's nothing you can actually combine together in this way that means anything logically, that could be used in an actual argument and actual discussion. So that's the general idea. Let's do one more, and then we're going to put this into practice. We're going to kind of put things together. So writing our statements, combining things together, putting things into symbolic form, and then using our truth tables. So how many operations do we have here? Well, we have a disjunction, we have a negation, a conjunction, and then another disjunction. So we have a total of 4 operations, which means we'll need 4 additional columns past the originals. So write our originals, okay, all the values for P, all the associated values for Q. Now notice here we have 2 sets of parentheses. So the very last thing we'll have to do will be the conjunction in the middle. We need to simplify everything in parentheses 1, everything in parentheses 2, and the final thing we'll do will be to join those together. So we're going to work left to right. That's just a good idea. When in doubt, if you have multiple sets of parentheses, just work left to right. Now, unlike with set operations where you can potentially do more than one thing at a time, that's not going to work here. Because what we're trying to do is we're trying to analyze with each operation, what does that do to the truth value or the value of falseness? Only one operation at a time, because each individual operation has a different effect on a true value or a false value. So you can only add in one operation at a time. You can't do more than one at one time. You can't really skip anything here. You've got to do one operation at a time. So you have 4 operations, you need 4 columns. So in our first set of parentheses, we've got our disjunction, we've got our negation. That means we'll have to start with the negation. Now this negation only applies to Q, which means at the moment we only need Q. So we're negating all of those values for Q. So true becomes false, false becomes true, and then true, false, false, true. Okay, now from negated Q, we're now combining it together with P with a disjunction. So in other words, an or. So at the moment, we don't need this column. We're combining P and not Q. So our next column is going to combine those 2 together. Now remember, with disjunction, only one has to be true. So true or false becomes true. True or true is true. False or false is false. False or true is true. Now this column, once we have this column done, that's going to be everything in the first set of parentheses. So we now have that fully simplified. These will be all the values that we then combine at the very end with this conjunction. Before we can do that though, we need to simplify the next set of parentheses. So P or Q. So you could cover up these two in the middle. If they're distracting, cover those up until you need them again. We're just looking at P and Q right now, so P or Q. So true or true is true. True or false is true. False or true is true. And false or false is false. So at the very end, we're now taking these two results and we're joining them together with a conjunction. In other words, the word and. So each of these truth values join together with the word and. So true and true gives us a true result. True and true is true. False and true is false. And true and false is false. So that's going to be our final truth values. So if we were to summarize what we see here in terms of whether or not this particular type of compound statement would be true, whether it would be false, one way to say it, notice what's in common here in terms of where we started versus here versus in terms of where we started. In this case, we could say that anytime the statement P is true, we're going to get a true result. And anytime the statement P is false, we're going to get a false result. And again, if we knew what P and Q were, and we could determine whether or not those original statements were true or false, then this particular column is going to give us a sense of what this structure means for those particular values for P and Q. So what if we have an actual statement? So all of this has been out of context. What if we have an actual statement and we want to determine whether an actual statement in English is true or false? This is where we're going to have to layer in the stuff we talked about in the last section. So we talked about how you translate things from symbols to words and from words to symbols. Well, here we want to go from words to symbols. The idea is if we can take something in English, in the actual written language, and then putting into something symbolic, then we have these kinds of techniques that we can apply in order to determine what we're looking at, in order to analyze the statement we have. So we have a couple different layers here. So we want to do this. First off, we want to write each statement in symbolic form. That's going to give us a way to analyze the statement logically. We're going to assign letters to simple statements. We want to make sure the statements we write are not negated. So if you see the word not, we're going to use the negation symbol. The actual statement has to be a positive statement. The word not will be indicated with negation. Then we're going to construct a truth table for the symbolic statement and determine at least one set of conditions that make the statement true, if we can find one. So here's our first statement. You did not do the dishes and you left the room a mess. Okay, how do you know how to write the statements? How do you know where to start here? Well, look for the connectives, look for things like not. So we're looking for and, we're looking for or, we're looking for not. Imagine taking those out of the statement for a moment because we know those are going to be represented symbolically. Anything left over represents a statement. So if you removed the not and the and, we still have you did the dishes and we have you left the room a mess. So those are two separate ideas. Those are going to be our two separate statements. So we're going to define P as you did the dishes, and we're going to define Q as you left the room a mess. Now again, notice we didn't say you did not do the dishes is our statement. We want our statements to be positive. That way we can use negation to represent the not. So if we were to take our statements and then translate our compound statement into symbols, you did not do the dishes is going to be not P, and is going to be conjunction. You left the room a mess is going to be Q. So this is going to be our symbolic statement. This is essentially a way of representing this particular sentence in symbols just based on the particular simple statements that we have. So now we want to know, when would this compound statement be considered true and when would this compound statement be considered false? What if we don't know whether or not you did the dishes or you left the room a mess? Maybe we don't know. all we can determine here is if it is true that this is the case, if it is true that this is the case, this would be the result. If one is true and the other is false, this is the result. So the truth table is just analyzing the situation in general. Okay, we're defining the truth table for this particular symbolic statement though. So based on the different possibilities for P and Q, we want to know what would result for the actual statement as a whole. So first thing we'll do is our negation, so not P. So we're taking all the values for P and we're negating them. So true negates to false, and then false negates to true. Then we're combining that negated statement, conjunction with Q. So forget about this column, you don't need it now. Combining the last two columns with conjunction. So conjunction will only be true when both of the original statements are true, both of the combined statements are true. So true and false gives us false, false and false gives us false, true and true gives us true, false and true gives us false. So if we look at the last column, there's only one set of conditions that actually lead us to a true conclusion. So the only way this statement, and more importantly, this statement, the only way that statement as a whole would be considered true is if the original statement P is false and the original statement Q is true. So if it is false that you did the dishes, and if it is true that you left the room a mess, then we could say that you did not do the dishes and you left the room a mess is a true statement. That would be our conclusion. So those would be the only conditions under which this statement is true. Sometimes there will be multiple conditions under which a statement is true. So for instance, the one above, there's two different sets of conditions that would result in a true conclusion. Typically, the more complicated the compound statement gets, it's more likely that you're going to find different situations where you're true. But it could also result where all are true, where all are false. It just depends on the way we're combining our simple statements together. Let's do one more. Okay, it is not true that I have a degree in English or a degree in history. Now, it is not true that. We talked about this wording in the last section. That is a very specific kind of wording used in a very specific way. So it is not true that, the fact that we have the not true, that means there's a negation involved. But when we use that particular wording, it means we're negating an entire compounded statement. So we have negation, and in this case, we're using the connective or. So we have a negation, we have a disjunction. But by using this wording to express the negation, what that tells us is that we're combining our two statements with an or, but we're negating the whole statement that results. Not just one statement, but the whole compound statement resulting from our disjunction. So imagine removing all of those parts temporarily so that we can define our simple statements. So I'm going to remove it is not true that, and I'm going to remove or. What remains is I have a degree in English, degree in history, which we could write as I have a degree in history. When we define the statements, we want them to be actual individual sentences. So even though when we combine them together, we may leave out some words just for brevity, when we write the simple statements, we want them to be actual sentences. So here it would be I have a degree in English, and then it would be I have a degree in history. So we'll call that P and we'll call that Q. Now when we structure this statement symbolically, or is going to be our disjunction. And then remember, the not applies to the entire disjunction based on this wording. So the way we'll indicate that is by putting our disjunction in parentheses. So I have a degree in English, or I have a degree in history, P or Q. It is not the case that. It means we're negating the whole disjunction. So this is the statement we want to assess the truth and the falseness of. Again, just based on the possible values for P and the possible values for Q. So here's our different combinations. Layering in one operation at a time, we start inside parentheses. So the disjunction comes first, one or the other. So anytime we have at least one true statement, the disjunction is going to be true. So true or true is true. True or false is true, false, true is true. If both are false, that's the only possibility that results in the disjunction being false. Now from that result, we then want to negate. So I don't need these anymore. I'm going to negate my last set of values. So true negated results in false, and then false negated results in true. So what that tells us is that the only set of conditions that result in a true conclusion are the conditions where the original statements are both false. What does that mean from the practical standpoint? Well, if I say that P and Q are false, what I'm saying is I don't have a degree in history, or in English, I don't have a degree in history. So the statement, it is not true that I have a degree in English or a degree in history, that whole compound statement would only be true if it's not the case that I have a degree in English, and it's not the case that I have a degree in history. So think of this as a way of taking a statement and breaking it down into components. Based on those individual components, we can analyze whether or not they're true or false if we have additional information added to the problem. We can analyze the structure of the statement just by converting it to symbols. And then we use this idea of the truth table, what happens from operation to operation based on different truth and falseness values, to analyze the statement as a whole.